Now, how do we actually build phylogenetic trees? We're going to have to follow what's called parsimony method. You want to build a tree that is going to have the fewest number of evolutionary events, because most likely what happens is the trait evolves once and then it gives rise to speciation. So basically you're going to have all these branches in the tree of life that will stem from that one. And because it's very unlikely that the traits evolved independently in separate lineages here and here and here. Let me show you what I mean by that. So for example, we have this hypothetical tree, and notice tuna and whale share a common ancestor right here, and then lizard, monkey, and a hippo, they share a common ancestor right here, and then we have a very distant common ancestor here. So you can see these traits 1 through 9 evolved in this lineage that gave rise to lizard, monkey, and a hippo. And then we have the same exact traits that evolved right here in this lineage that gave rise to just whale. So it means we have a lot of evolutionary events happening here independently. So what happened most likely is that these traits evolved once, and that's how we get all the branching in a tree. Now we have tuna, lizard, monkey, and a hippo, and a whale sharing that common ancestor here. So this would be accepted phylogenetic tree because it has fewest number of evolutionary events that sort of tie these organisms together. If you want to pause here, go ahead and see which tree would actually meet the parsimony method. Remember, you have to look at the number of evolutionary events, and whichever tree has the fewest number, the lowest count, that would be the acceptable phylogeny. So go ahead and pause here and examine these trees and see the differences. Okay. Alright, so let's take a look at one example of how we can actually build a tree. So you can see we have 3 organisms and there's one outgroup. So 3 taxon that we are interested in, and they have specific character states. So the very first thing you want to do is, once you look at each individual trait and who shares that particular trait, you're going to ignore autapomorphies, meaning anything that's unique, you're just going to put it aside right now and not worry about it, because they're not going to be very helpful in the beginning how to put it, how to build this when you're gonna try to build this tree. Another thing you want to do is ignore traits that are shared by an in-group. So it means everyone has it, so you're still not gonna be able to sort of put them together into that into the tree and show evolutionary relationship. So what we want to do, we want to count the traits that are shared by subset of in-group. So let's take a look what we have here. Notice trait A. No one has it except the outgroup. Trait B, no one has it except the outgroup, so we're going to ignore that. And then trait C, notice how everyone has it except the outgroup. So now we say, okay, let's just ignore that for a while, for a minute, okay, because everyone has it. It's not really helpful. And then we continue on. So we have trait D and E. You can see organism number 1 is sharing those 2, but they are unique only to them. So it means these are autapomorphies. So we're going to leave them alone for right now. And then here we go. We're getting somewhere. So look at the traits F and G. Do you see organisms 2 and 3 are sharing those 2 traits? So it means 2 and 3, that's an idea that maybe they are actually sharing common ancestor because they have something in common. And then we have H. That means, notice this is something that's unique to only organism number 2, so we're going to ignore that. And J is unique to number 3, so we're going to ignore that. So this is what we have here. So we identify 2 and 3 as possibly being sharing a common ancestor. So then what we want to do, we want to compare each organism to each other and see how many similarities or how many differences they have. So I've went ahead and I counted how many overall similarities they have. 1 and 2 has 4, 1 and 3 has 5, and then 2 and 3, you can see they have overall 7 similarities. So that is another indication that possibly 2 and 3 are sharing that common ancestor. And the next thing you want to do is compare each taxon to the outgroup and see, you know, how many differences you have there, or how many similarities. You can use any angle you want here. So I went ahead and compared 1 to 4, and I found 5 similarities, and 2 to 4 has 3, and 3 to 4 has 4. So it means now we're getting somewhere. We can actually place these organisms in somewhat of an order as far as evolutionary progression and relationship goes. So notice what we have here, the 4 being as the outgroup. The next one would be 5 because it's most similar to the 4. The next one would be 1 because it's most similar to 4. And then we would put 3 and then followed by 2. You can see fewest number of similarities compared to the outgroup. And now all we have to do is build a tree, show a visual representation. So let's get going. This is going to be my outgroup. This is going to be organism number 1, organism number 3, and organism number 2. So you can see 3 and 2 are sharing common ancestor. Yep, they share those 2 traits. And you can also go ahead and mark those traits in the phylogenetic tree. So for example, trait A, since only the outgroup has it, so we would put a tick mark and we'll put A. And then B, also a tick mark. Here's another one. And then we have C, everybody has it, so we're going to put a tick mark right here. Organisms 1, 2, and 3 have it. And then we have D, unique to only 1, so we're going to put D. E is also unique. And then we have F and G shared by these 2 guys, so we're going to put F and G, so F and G. And then we have H, that's unique to 2, so we'll put H. And then the I is also unique to 2. And the last one is J, unique to 3. So there you go. You have phylogenetic tree that shows all the evolutionary events. So that is one way to approach, you know, how you can build those trees. You can have another method, but this would be my thought process, you know, as far as, but remember, you got to compare these organisms. And the idea is to build a tree that follows the maximum parsimony method. All right, so now remember you have a handout to practice reading those phylogenetic trees, so make sure you look over them and practice. All right.